We're going to continue on in section 6.2, and we're going to use Pascal's triangle to expand binomial expressions. So just a reminder, a binomial has two terms, and binomial expansion is a quicker way of expanding or multiplying out a binomial expression that has been raised to a large power. So when we say expand, this means 6m minus 8 times 6m minus 8 times 6m minus 8. What it does not mean is cube this and cube this. So it does not equal 6m cubed minus 8 cubed. So I'm just put a cross through that. When you use Pascal's triangle to expand a binomial, you will only need 3 rows to set up your problem. And it doesn't matter what the exponent on your binomial is. Each problem only requires 3 rows, and then you simplify or multiply out. So the first thing that we need to talk about is Pascal's triangle. And Pascal's triangle, you want to know that the first row is row 0. So we don't number them like a normal numbering rows. But this is row 0, this is row 1, this is row 2, this is row 3, row 4. So if you notice, the second number in each row is the row number. The first and last number in each row is 1. The second number in the row is generated. Let's see, the second number in the row is the row, or the degree. So it's a row number, but it's also the degree that the binomial is raised to. And each number in the row is generated by adding the 2 numbers diagonally above it. So if we want to find the numbers in row 6 of Pascal's triangle, we put a row 1 in the beginning, 1 at the end. We add these 2 numbers, those 2 numbers, that's 15, 20, 15, and 5. Okay, so we can just kind of point up to here what those numbers are, or it might be better if I write them out because they're kind of smushed together here. So 1, 6, 15, 20, 15, 5, and 1. Okay, the way that you use Pascal's triangle, I showed in class how much work it takes to actually multiply that out, several rows to simplify. But with Pascal's triangle, what we need to do is we need to go the numbers in row, we're going to take the degree, and that's going to tell us which row to go to. So if I go slide back up here, I look at the second number that tells me my row number. So these are the numbers that I want, and I'll write them in the first row. 1, 3, 3, 1. Okay, now, the second row is the first term raised to the exponent, then decreased by 1. So our first term is 6m. I'm going to write that 6m all the way across, and then I'm going to raise it to the exponent. My exponent here is 3. And then I'm going to decrease it by 1. So it's 3, 2, 1, and 0. The second term is raised to the 0 power, and then we increase it by 1. So the second term, always take the sign with the number. That's going to be minus 8. So here's negative 8 all the way across, and then I raise it to the 0 power, and I go up by 1. So what's going to happen with the exponents, if I add the exponents in these 2 rows, they should always equal 3. There's 3, there's 3, there's 3, and there's 3. Okay, now I am going to simplify what this is. I'm going to make this a little bit smaller so it doesn't take up so much room. 6m cubed. Okay, now I'm going to write what those values equal. So I have to cube the 6, I have to cube the m, so this is going to be 216m cubed. There's another pen here, I think my ink's going out. 216m cubed. This is going to be 36m squared This is going to be 6m, and this is going to be 1. Anything to the 0 power is 1. Same thing here. Anything to the 0 power, doesn't matter if it's negative or positive, it's going to be 1. And negative 8 to the first power is going to be negative 8. Negative 8 squared is going to be 64. And negative 8 cubed is going to be negative 512. Okay, once I have all of this set up, I'm just going to multiply down the columns. So multiplying all of this, I get 216 m cubed. And then I go to this column, and I multiply 3 times 36m squared times negative 8. And that's going to give me negative 864m squared. And then the 3 times 6m times 64 is going to give me plus 1,152. And then I'm going to multiply the 1 times negative 512, so minus 512. And that is the polynomial that I would get if I would multiply this binomial out by itself 3 times. Okay, now you have a problem to try.